Welcome back, Frank and friends. I'm Greg Smith, aka Dr. Frankentosh, and today on Dr. Frankentosh we're going to do part 3 in my series on object-oriented programming in C, inheritance. In part 1 we looked at encapsulation, in part 2 we looked at polymorphism, and today we're going to create a class structure so that we can inherit from a more general class into a more specific class until finally we have a concrete class. So stay tuned for inheritance on Dr. Frankentosh right after this. So before we get too carried away writing code, let's talk a little bit about what inheritance looks like. Now we saw a bit of this last time when we worked on the pulse width modulation LED, that we inherited some values from the parent class, which was the flashing blinking LED. So what I'm going to do now is refactor that code. I'm going to take pieces out of the LED and I'm going to put it into another class. So at the very top of all of this, we're going to have a very generic object. That's what G-O-B-J, generic object. And that is the root or base class. And below that then we'll have a class that just manages GPIO pins. And then from that, we will have two subclasses, one that does GPIO inputs and one that does GPIO outputs. And under this class, we could create a GPIO button. And then over here under the output, we'll have our blinking LED. And under that, we'll have our pulse width modulation LED. Members associated with the G-object, we're going to have a name, and we'll have a debug method and a destroy method for freeing the object up. GPIO will have a reset method to reset the pin, and GPIO input will have a get method, and GPIO output will have a set method. And as before, our LED classes will have a blink method. So it's useful to know what your object hierarchy looks like so that you know what inherits from what and what capabilities you have from previous. And the advantage of using this sort of inheritance is that all of these elements, the name, the debug, and destroy, pass down to the children. The reset then also passes down to its children. The get method will pass down to the button method, and then the set method will be used in both the LED blink and the pulse width modulation blink. Let's go to the code and see what that looks like. So before we get started, it might be useful to go back and look at the main program from our last segment. If you remember, we had the PWM class. We created a red LED, a green LED that just blinks, any LED that blinks faster. Here's the loop where we blink the LEDs, and then we check the boot select button and set its state, and then call the duty cycle code in the event of a button click. So in the new main, things are a little bit different. Now we still initialize our LEDs. I've renamed the class slightly, but I also created this XButton class, which checks the GPIO input. And in this case, we're looking at GPIO 5. And it's cleaned up our logic quite a bit. We can say if the button is clicked, in other words, somebody pressed it down and then released it, then go call the update duty cycle code, which I've refactored to be just outside the main function. So this cleans up our code quite a bit, makes it much easier to read. And because these blink and button click methods do not hang, in other words, they're not calling a sleep function and they're not looping, waiting for the button to be released, we can have our blinking LEDs, and these all look like very independent, real-time multitasking tasks, which is our ultimate goal. Now let's go look at the way that I refactored the code so that we have an object hierarchy. So the first thing I did was I created a new object called G-object, which is the base class. Every object will have its own name, every object will have a debug method, and every object will have a delete method, which frees any memory that the object might have when you're done with it. And also if there's any cleanup to do, for example, with GPIO pins, this is where you would do that cleanup. Now, I'm going to come back to this, but I originally had an initialization method, and I decided to do away with it. And when I did, it created a very difficult to find bug. And this foreshadows the next segment where we talk about how to manage proper superclasses. So here's the base object, and here's the implementation of the base object. To create a new base object, we just set the name, the debug method, and the delete method. Again, every new object will have a name. And then if we call debug, it will print out the name of the object followed by whatever message we pass in. And if we decide to delete the object, it simply frees the memory associated with it. So now let's go down a layer and let's look at GPIO.h. Here's the interface. Again, we include G-object because that's our superclass. Now we're going to hand copy in all of the members that have to do with G-object, and then we'll extend G-object to include the pin, the direction of the GPIO, and how to reset the GPIO. So let's take a look at the implementation of that class. Again, we pass in the name, the pin, and the direction. We call the G-object new with the current object. It then initializes it, sets up all the pointers and the values that the base class needs, and then extends the class by setting the pin, the direction, and the reset method. And then we actually call the reset method. So jump up here, we have to go get the global this variable, we call GPIO init and GPIO set dir. Once again, using this object-oriented approach, we will never have to memorize or look up any of the SDK functions because they're going to be encapsulated inside our GPIO object. All right, let's go look at the next class, which is our GPIO input. And once again, because we're inheriting from GPIO, we have to copy all of the members from GPIO and then extend the GPIO with the GPIO input. And then the only thing we're adding is a get method. And what's significant here is you can never call set on a GPIO input. You may have made this mistake in your own code when you set a pin to be an input and you tried to set it to an output. You tried to set its value. And you will never have that error in this case because the set method isn't even an option on GPIO input. So as with the other GPIO, so here's the implementation of the GPIO input. Here's the constructor. The constructor will allocate memory if necessary. Then it calls GPIO new to initialize the object, set its name, its pin, and the direction. Notice that as an input constructor, we don't have to specify the direction. It's going to be done for us. It's also instructive to see what the GPIO initializer does for us, in that not only does it set the pin and the direction, but it also calls reset for us. So it's automatically setting the pin up for us. And then, of course, when we do the get on the input, it calls GPIO get for us, passes in the pin number. We never have to memorize this, and it will get the value and return it to us. Let's take a look at GPIO output. Again, because we're importing from GPIO.h, we hand copy all of the GPIO members, and then we extend it with the set method, which accepts a value. And once again, the GPIO output constructor just takes a name and a pin. Let's look at the implementation. And here you can see we pass in the name and the pin. Just like we did with the input, we now call the GPIO new method and initialize it as an output, and then we set the set method. And the set method then just takes a value and calls GPIO put, but it returns no value. Now, a couple things that I've kind of glossed over here that I want to point out because it's really the big power and the big capability that we get with object-oriented programming. There's very little code here in the implementation of GPIO output. And that's because we already have the majority of the code for handling a GPIO here in GPIO new. And that also has some capabilities that we get from G-object, like the delete and the debug, and also the initialization. So by adding on or extending these classes, we keep our code very, very simple, and we don't have to add that much code to get new functionality. Now let's take a look at the blink class. So as before, we're including everything from GPIO output, so we have to hand copy all of the members that come from GPIO output, and then we extend the class with the state, the delay, the last time, and the blink method. And in the implementation, again, very simple. We have a constructor that takes the name, the pin, and the delay that we want the LED to flash with. We then allocate the memory. We call GPIO output to initialize the LED pin, and we set the state, the delay, the last time it blinked, and we set the blink method. LED PWM, if you look at that, now this includes from LED blink, so we include everything that LED blink did up to the blink method, and then we extend it with the cycles, which is the number of milliseconds per cycle, the duty cycle, the duty delay on, the delay off, and the set duty cycle method. So let's look at the implementation. Again, very simple. We call LED blink to initialize everything. Again, this is a GPIO output, so all of that is taken care of for us. We update the blink method. We are overriding the LED blink method from the original LED blink class. We're setting the number of milliseconds per cycle. We're setting the duty cycle method, and then we call the duty cycle method to set up our blinking LED. And we have our own new pulse width modulation blink method from the last segment. And finally, let's take a look at our X button. Here's the header. Now this includes from GPIO input. So I've copied all of the members from GPIO input, and I've extended it with whether or not the button was pressed, and to 3 new methods. Is pressed, meaning is the button currently down, is released, meaning has the button been released, and is clicked, meaning has it been pressed, and then subsequently released. So let's take a look at the implementation. Once again, very simple. Here's the constructor. We call the GPIO input initialization. We set the is clicked, is pressed, and is released methods. And then up here, is pressed simply calls this get, which means it's going to get the get method from GPIO input and return whatever that returns. Is released, it's going to call the get method again, but it returns not that. So if it's down, it will return up, and if it's up, it will return down. In other words, it's just checking to see if the button's been released. And then finally, the is clicked method. You may remember this from when we looked at the code in the main. We check to see if it was pressed, and if it was not pressed last time, and it is pressed this time, we simply update the was pressed state to being yes, it was pressed. But if it was pressed last time, but it's been released this time, we reset the was pressed button, and we set clicked to 1, and finally we return clicked. So most of the time, this is going to return 0, meaning it's not clicked, but only if it was previously pressed, and then on the next iteration it was released, then we will return 1, meaning it was clicked, or that means it was down, and then it was up. One last thing I want to mention, if you remember from last time, and I'll pull this up as an example, we'll look at the LED code from last time. You may notice that what I'll call a namespace was on the front of every one of these methods. So it was LED init and LED blink. And if you look at pwm.c, pwm blink, and pwm set duty cycle. And you really need to do this because in the old method, because these are global variables. They are what's called extern. You can visibly see them externally. And if you have more than one method with the same name, like blink, there's a collision, and the compiler will complain that you have the same variable defined twice. But we get around that. You may notice now that this is the blink method, but it doesn't have that namespace on the front of it. And that's because this is being declared static. And a static member or static method is local to this file. It's not visible outside this file. This gives us a little bit of privacy and the ability to reuse method names and not have to make them really, really long like we've seen in some of the Pico SDK. So this is the name, it's blink. And down here, when we set the blink member to the blink method, we don't have to put LED PWM underscore on the front. It knows it's this one up here, and it's not going to confuse it with a blink method in some other class. So looking at our main code again, you can see here we've created an LED PWM, which is red. It's on pin 6, and it has the duty cycle from above. We have our green blink LED, which is on pin 7. It blinks every 500 milliseconds. Our yellow LED, which is on pin 8, and blinks every 250 milliseconds, or 1/4 second. And then we have our X button, which is on pin 5. And then we just iterate forever. We blink the red LED, we blink the green LED, and we blink the yellow LED, and then we check to see if the button has been clicked. If it has, we update the duty cycle and continue on. So let's go to the video and see how that looks. So you can see here, I've wired this up the same as last time, and I've added a new push button that is connected to GPIO 5. And as I click the push button, it changes the flashing rate on our pulse width modulation LED, and the other LEDs continue to blink. Okay, so there is a nagging problem with this method, and I'm sure you've figured this out. This business of hand copying the superclass members to the subclass is error prone. And in fact, when I was writing this code, I originally thought that I would have an initialization method. And so I was hand copying this init pointer to the next subclass. And then I went back and I decided I didn't need an initialization function. And I took this out. And this init pointer propagated to all of the children classes. And when it did that, it pushed all of these other members down. And so when I was calling, for example, the debug method, it didn't know that I had taken this init method out. And so I called debug, and it was looking for it in the second slot. But when I called it with a GPIO, it was expecting it in the third slot. And this caused an immediate bug in my code. The application crashed, and I had to go figure out why this was. So in the next segment, we're going to use macros to create an inheritance mechanism that will save us from all of this trouble. So in the past, I've talked about syntactic sugar. This is a way of using the syntax of the language to make things easier on us so that we don't have to type as much. But in this case, we're going to apply the C preprocessor's macro capability to not just give us syntactic sugar to make things easier on us from a typing point of view or from a visual point of view, but it's actually a very practical thing that we're going to do, a very practical value that we get out of this. So as I mentioned last time, I had originally included a void pointer to an init method here, and then when I took it out, it caused the other classes to have an offset that was different than the original GObject. So what we really want is a method of being able to modify our parent classes so that the child classes actually inherit from the parent. So here's how we're going to do that. We're going to do a pound define of GObject members. And for every member, we're going to put that underneath this define. And notice this backslash here at the end of this line of code. This is a continuation character, which means that everything underneath here is part of this same macro. And then down here, what I'm going to do is put GObject members there, and that's going to expand these members directly underneath this structure. So I know that it looks a little confusing. We define our members up here, and then we expand them down here, but it makes sense when you look at the next step. So let's go to GPIO.h. So notice here that these are all the members that come from the GObject class. So what if we now do the same thing that we did before with the GObject, but now we use it for GPIO members. And we want the 3 members that are unique to GPIO, but we also want to expand the GObject members. So what this does is it actually, as a macro, it does exactly the same thing that we were doing by hand, which is it takes the GObject members and copies them into the structure, and then adds on the additional members that we are adding to GPIO. And so we can get that by just going here and expanding that macro. And then we repeat the process. Now, what's significant here, and again, remember what my error was before, was that when I hand copied these members down, I kept this init method in here, but I had deleted it from GObject members. And this solves this problem. If I remove something or even add something to GObject, everything that inherits from GObject is also going to inherit that method. So this is a very simple fix to a complicated problem. It means we no longer have to copy and paste our parent superclass members. It's done for us automatically as part of the C preprocessor. And so we'll do this. In fact, let me go ahead and show you. I've already done this. So there's GObject with its GObject members. When I go to GPIO.h, here's the superclass. I include GObject.h. I then expand the GObject members macro and then add on or extend the GPIO members. GPIO input, exactly the same thing. Here are the members for our GPIO input. Here are the members from the parent class, which is GPIO, and I extend it with just a single get method. And the other thing this does is it really makes clear what you're getting from your superclass and what you're extending in your new class. here's GPIO output members. So we got the GPIO members, we expand that, and then we just add the one set method, and then down here we fill in the actual GPIO object. LED blink, these members are from GPIO output, and then we extend it with the additional state delay last time in blink. LED PWM, in this case, we are including or extending from the LED blink class. So here's the LED blink superclass members, and then all the things that we're adding to that class to make this a LED PWM. And then finally, our xButton.h, we're extending the GPIO input. Here are the xButton members, and then we are getting the input members, and we are extending that by adding the was pressed, and is released, and is clicked methods. And we compile this, and it compiles cleanly, and if ever we go back and modify some parent class like this, we don't want the init method anymore, all of the child classes will automatically inherit that change. So we've successfully added inheritance to our object-oriented programming in C methodology. But there is still one last problem, and that is the fact, and you may have noticed it, that our objects were getting pretty big. And in fact, the majority, maybe half of the members that we had in these objects were the methods that were associated with them. But the problem is that those methods don't really change. You can have a dozen of these LED blink classes, and those methods are all the same pointer values, right? And so that's pretty inefficient, and it makes for very thick objects. So what we're going to do in the next segment is create virtual functions, and we're going to split out the methods from the instance object and create a class object that's just composed of methods. And then we'll point to that class object, and when we make those method calls, we're going to go down the class pointer to the class object that holds all of those method calls, and we're going to skinny up our instance objects. So please tune in next time. And as usual, please don't subscribe to my channel. Please don't click up there or down there. Don't like this video. Your time is precious. Please don't waste it. But thank you very much for spending part of it with me. And I'll see you next time on Dr. Frankentosh.